Greetings, geniuses. We have reached our last page of 1.3, and let's get to it. Use a graphing calculator to graph the function and determine whether it's even, odd, or neither. So we come back to even and odd functions. Gives me a good opportunity to talk about this. A function is even when for each x in the domain, all of our right lefts of f of negative x equals f of x. A good way to say it, a bad way to think about it. This is the height. We can think of that. This is the height to the left is the same as the height to the right. For instance, this function. The height to the left of the graph appears to be height to the right. It looks like it folds over the y-axis. This one appears to be even. A function is odd when for each x in the domain, the height to the left is the opposite of the height to the right. The height to the left, let's say this is 2, 2, and this is negative 2, negative 2. The height to the left is the opposite of the height to the right. The height to the left is the opposite of the height to the right. And generally speaking, most functions are neither. So here we go. We're supposed to use graphing calculator. I would not on number 66, just because pretty straightforward here. 1, 2, 3, 4. We got a y-intercept of 4, a slope of negative 1. Our graph looks like that. And at first thought we might say, well, it's definitely not even, but this spins around onto there. However, the height to the right here is, if I go 1, the height to the right is negative 1. The height to the left, 1, is not positive 1. Therefore, this is neither. It needs to spin around the origin onto itself, like you can visualize this one spinning around the origin 180. This one spinning around the origin 180. Notice it's on the origin. Whereas the one we were just looking at, if I spin that around the origin 180, I actually get, if I spin it around the origin here 180, we'd actually get something like, I'll just emphasize this with a big dot. We'd get the big dot would spin up to here, the arrow would spin down to there. So it doesn't spin onto itself. Okay, negative x squared minus 8. I hope perhaps maybe we know what that looks like already, but if not, we are going to soon. Here we have negative x squared minus 8. And if I do that in Zoom Standard, it might not be completely satisfying, but maybe we'll have enough information there. That might be a case where we want to jump to our window and let our y's go down a little further. Maybe let our y's go down to negative 20. So we've got, when x is 0, this has got to be down at negative 8. 1, 2, 3, 4, 5, 6, 7, 8. And it looks something like that. And it definitely appears as though the heights to the left are the same as the heights to the right, the same distance. So this most definitely appears to be even. Okay, y, clear. Third root, couple ways we can handle this. We could do this, I'm going to show you both. Parentheses x minus 1. Close parentheses, raised to the 1 divided by 3. And to be perfectly honest, I'm so entrenched in not having this much technology that that's the way I would do this. However, you can go alpha window. There's our root picker right here. And you can go third root of x minus 1. And you probably would prefer that. So I'm going to go back to Zoom 10, or Zoom 6, excuse me, Zoom Standard. Let's take a look. Okay, sneaky one. Look at that. Looks like the most interesting thing that's happening is happening right at 1. And, well, how about that? sort of as expected, we've got a graph that looks like this. And we say, well, that spins around itself and lands on itself, but it does that if I spin here, like a propeller on a plane. It would land on itself. It does not if I spin here. So this is neither even nor odd. The height to the right one is 0. The height to the left one is not negative 0. It's negative something else. So this is a neither. All right, I like these problems. They're quick, but they also show that you have a really good understanding. What you do not want to do is memorize a pattern on this. You want to understand. You memorize a pattern, and that will fail you down the road when we take a test or a final, or you're talking about it next year. So, find the coordinates of a second point on the graph of f if the given point is on the graph of a function that is even. So I'm going to just sketch this. We're at negative 5/3, negative 7, something like that. If it's even, the height to the left equals the height to the right. And the height to the left 5/3 is down negative 7. So the height to the right 5/3 must also be down 7 for the heights to be equal. So A is 5/3, but stay negative 7. And I'm going to tell you, I would have, once we're done with 50, 74, 76, 78, I would have just memorized. Don't do it. Keep going through this height to the left equals height to the right. For B, for an odd function, the height to the left is the opposite of the height to the right. So our height to the left, if to the left we're down 7, to the right the same distance, we would be up 7. So 5/3 would get us up 7. And yes, you could just use what happened in A and B and model these other after it and leave here not understanding what even and odd functions are. So don't do that. To the right, 5, down 1. A, even, so the height to the left would be the same as the height to the right, would be left 5, down 1. Odd, the height to the left 5 would be the opposite of negative 1, would be positive 1. Okay, let's make certain we've got that. Now, because I don't know if A and C are positive or negative, I'm just going to assume they're both positive. So we go to the right 2A and we go up to 2C. And now we want even, where it says the height to the left is the same as the height to the right. And odd, where the height to the left, that distance, is the opposite. So that would be left 2A, down 2C for part B. Okay, and then the algebraic process. You can do this with graphing calculator, but we kind of did that up in 65 through 70. So I'm looking at just this first part. Is determine. We're not even going to have a graph. Here's the algebraic process for determining if a function is even, odd, or neither. And to be perfectly honest with you, those of you who will remember this will have an advantage on the test, because I'm not going to directly say what I'm about to say on the test. So here it goes. There will be a question very much talking about this little mini section on your test. What we want to do to determine if it's even, then f of negative x equals f of x. The height to the left equals height to the right. If it's odd, the height to the left equals the opposite of the height to the right. This is the height to the right. I want to find out what happens with the height to the left. So I'm going to put negative x in this function, and I get negative x to the sixth minus 2 times negative x squared plus 3. But negative x to the sixth, the negatives get absorbed. There's an even number of negatives, so that's just x to the sixth. Negatives are absorbed here. It's to an even, negative to an even. So minus 2x squared plus 3. And now I take a look and I'm like, well, the height to the right is the same as the height to the left. This is even. And you will leave here thinking it's all about the exponents. And when we're dealing with polynomials like these first two, it is all about the exponents. But it is not all about the exponents when we're dealing with other types of functions rather than just plain old polynomials. These are all 79, 80, 81, 82 are all polynomials. Okay, so what happens to the left? You told me what happens to the right. I get negative x to the fifth minus 4 negative x to the third. 5 negatives is negative. 3 negatives is negative times a negative is positive. And this, h of x times negative 1, if I take x to the fifth minus 4x cubed, multiply it by negative 1, like this is negative 1 times f of x, I get negative x to the fifth plus 4x cubed. So the height to the left is the opposite of the height to the right. This one is odd. And this guy, f of negative s, is like my least favorite variable. I got to really slow down because I make it look like 5s. Equals 4 negative s, see that? I warned you, to the 3/5, which could be written as 4. In this fraction, the numerator makes this s bigger. The 5 makes it smaller. The root makes it smaller, so 5 makes this fraction smaller. 5 makes this negative s smaller. This 3 makes it bigger. 3 becomes an exponent. There's another way of thinking of this. And when I take the fifth root of negative 5, we can do that and raise that to the third. The negative survives the fifth root. The negative survives the third root. So this just becomes times negative fifth root of s to the third, or s to the 3/5. Notice the difference here. That negative was inside here, but negative to the third and fifth root of negative survive, so this just becomes negative 4s to the 3/5, which is precisely negative 1 times this. Therefore, the height to the left, there's the left right here, is the opposite of the height to the right. This one's odd as well. So another page, pretty quick. I'm going to guess maybe about 10 minutes. You can get through that. Fair amount of calculator work up at the top. And that will wrap up 1.3.